Okay, so welcome to the AI Agent Mobile Meetup. It's a little reminder, it's a meetup for people curious about AI, but we want to share and spread also best practices. And today we have the amazing opportunity to have Benedikt for his talk, Agents Across the SDLC, Software Development Lifecycle, from Refinement to Retro. I'm really excited to see the impact on the entire SDLC. Because most of the time we see only the impact on the coding part, So we'll see this in your talk. Just for the organization, the talk is recorded, as you know, and I will share it on our YouTube channel. Feel free to see it again. Feel free to ask any question in the chat, and we'll try to answer it along the presentation at the end, depending on you, Benedikt. And that's it. Thanks to be with us, Benedikt. The place is yours.
Yeah, thank you so much. Happy to be here. Really looking forward to talking with you about our experiences with using agentic AI along the whole software development lifecycle. Why do I say we? So I founded a company a few months ago called Hackers and Wizards, and what we do is we help companies actually to implement agentic software engineering in their own processes, in their own engineering departments, product management departments, and that's what we do. And my idea is just to kind of, so I'm an engineer and so on, right? You don't need to know about. Let's just go right into the topic, right? I think it's the most interesting thing. So I want to demonstrate you a little bit in Claude Code so that we see a few kind of practical things, and then I want to switch over to drawing some diagrams also, and switching from Claude Code to the diagrams and back and forth, right? A lot of you probably already have a lot of knowledge around these agents, but I think it's still worth to show something in the terminal as well. So let's maybe start with that. And let me see. You should.
Yes, I'm really interested to see also where you use AI agents, but for other part of like refinement or retro.
Yeah, exactly. So I want to kind of do a little bit of a kind of cold start here in terms of our cold water start, like go, or maybe is it hot start? I don't know. In German, you would say throw someone into the cold water. And I don't know how to say that in English, but basically, I am in a repository here. You can see it, right? In this, can you see the screen that I'm sharing?
Yes, but it's yes, we see.
Yeah. Okay. So what you can see here is that I have a Next.js project here, I mean, this is something that you all know already. You can just say like, what is this project about, and then you can see the details. But what is kind of interesting is that what usually people forget is that as you said, you can also use it to do requirements engineering instead of focusing too much on the code. And one of the first examples that I want to do is with you is I want to show you how I use it for requirements engineering. And a lot of use cases that we have are migrations. So one from an older system to a newer system, or from basically let's say you are working in a system and you want to work with Claude Code in the system, but there are no documented requirements yet. This is also kind of a bad situation. And what you can do is you can try to derive all the existing requirements from the code that you have. So this is one thing that I find really interesting for requirements engineering. And I just wanted to demonstrate it here. So you can say something like analyze, let's say like analyze this application.
Okay.
Should I make it bigger?
Yeah, the goal is to analyze and understand the legacy code, in order to make the migration.
Exactly. Yeah, exactly. So you can say like analyze this application and extract all implemented. Business rules, something like that. No specs yet. I mean, like analyze only the code, maybe, and give me let's say like rule name.
It's to have a big picture of the code base, yeah.
Yeah, exactly. I mean, you need to have it for if you want to write new stories into it. You also need it to know what is already in the I'm sorry, it's hard to tell. Something like that, right?
It's difficult to do that. That's right.
Yeah, yeah. So what I want to achieve is I want to kind of know what is in the application, and I need to know that for different things, right? I need to know it because I want to write new user stories, and that's why I need to know what's already in there. And also, I want, if there is no very good documentation about all of these features, and I want to migrate some or extend some features, I also would need to have a very good overview of what is actually already in functionality in the system. So first step for me when doing requirements engineering is always to kind of figuring out what is actually in there at the moment, right? Either by having that already somewhere or by deriving it from the existing application. And this is just like a short demo, right? It's a smaller project. It's just to get you a little bit of give you a little bit of an idea that the first step is not always kind of here's the user story implemented now. It's more like figuring out what the actual user story should be. So doing a little more product management than usual, right? Usually you are the developer doing the software and the coding, and now you kind of need to figure out how actually the product owners are working.
And this can help also for the onboarding part. Yeah, you know, when you have a junior, in order to understand the code base, the existing code base, or.
Yeah, exactly. I mean, we are writing the code not to write the code, but to kind of address some feature or some business requirement. And it's also helpful to know these requirements, right? And not only know the code. And if I'm in the role of someone who wants to decide how to extend the application with more features, then I need to know which are there, right? And for junior developers, I think it's also like let's say for new team members in general, right?
Yeah.
They need to know what is in there and kind of and as I said, also when you don't have that document, I mean, most software is developed with an issue ticketing system and so on, and then you have a lot of these information in the ticketing system already, but maybe not, right? We have a lot of migration cases as well, and in these migration cases, you often don't really have a like ticketing system where you can see, oh, this were the tickets that were implemented, or these were the features. That you only have the code, and then you need to kind of figure that out.
So source of trust, you know.
Yeah, exactly. And now you can see that actually this is something where Claude Code actually is very good at as well. So what happened here is now I only said like analyze and like a really stupid prompt. And it now figured out for example, authentication and then session rules, and also where it is implemented and the business description for this particular use case or for the requirement, token-based session, password never exposed, and so on, right? Like, and then it continues with authorization, access control, and so on. So it gives me a quite detailed list of all the features that are in there.
And did it give you also some information about the test or not?
I think there are no tests here in this application, so that's why it didn't do that. But you're right. If there would have been tests, then it would have shown me. And this would actually be like one of the next steps that you could do, right? If you see that there are no tests, then you could kind of figure that out. But what I find interesting is what I wanted is like, this demo is just like a little bit to get a practical idea of how that would look like, because in a moment I will draw a lot of diagrams and then it will not be practical anymore. But to get a little bit of a practical idea, I now can kind of work with this list of features and continue prompting to save that somewhere, to kind of create a documentation out of that and so on. But what I could also do is I could just say, based on this current status, state, I want you to propose obviously missing features. Right?
I have
Sure.
an
Go ahead.
additional question. He extract 35 business rules, but if you execute another timer, he extract again 35 business rules, or it's deterministic.
Okay. No,
Deterministic.
I don't think so.
Okay.
So because what I mean, this was a very stupid prompt here, right? So when I do it a second time, it will probably not be able to produce the exact same result. Maybe it will have like 40 or 30 or something like that, right?
Okay.
But it will still. I mean, if you want to be deterministic, you would need to kind of prompt it in this way to be like very thorough and to make sure that everything is covered, and also to let it run the same prompt multiple times. That is also something that is very helpful. So if I would now do the same prompt and just say
it's for
again,
understand, for example, if you execute twice or
and figure out if you were correct or missed something, present me the updated list, then it will probably figure out that like he missed 3, or it were like, and a good idea to get this deterministic behavior is to actually just run the same prompt multiple times, right?
Okay.
I'm not sure if you've seen that there's this Valve loop going on, which is kind of the gold standard idea of doing some. I mean, it's currently a very, very popular idea to get more determinism in the system, or like in the system. What you want is I just use the same prompt and do it over and over again.
And he extracts the business rule so quickly. So.
I mean it's kind of like a brute force way of doing it, right? Just doing it multiple times. Okay, but maybe let's see. I mean, as you said, this thing is now like, I mean, if you have a large application, it's also kind of helpful if you start first with prompting it to figure out the multiple domains of the system and then do this one by one per domain. But the idea is we are not talking about code here yet, right? We are not writing code. We are figuring out what the features are. And actually, where this is implemented is in this. I mean, it's nice, but I don't really care about that at the moment. I want to figure out what the problems are in this. I want to figure out which problems the system is solving for the user that are using the system.
It's a business point of view,
Yeah, exactly. Like the product side, right? And okay, now it's kind of taking a while here to really reassess all of that. But the next thing I can already say, write it down here. What I want to do is I'm a product manager, right? I'm not a coder in this scenario. So I want to know like which features are obviously missing. Write, let's say like 5 user stories. In the let's give it a format, right? So and when this makes it more deterministic, right? So that I say as a, let's say like role, I want to function as so that maybe like this, right? I mean that I can really say this is the format that I want, and then add acceptance. And I mean, usually you would have like a definition of done. It would be like a lot of stuff in place already. But in this short benefit, let's just say like acceptance criteria. And one thing I really enjoy is you can also say like prioritize them by business value or something like that, right? That you say like I want to prioritize them. Okay, as you see, it did a detailed analysis, and what you can see now is that it has 48 now. 13 were missed, and 2 were splitted because they were too big. And I'm sure if I do that again now, we will probably have like maybe 1 less, right? Or 2 more or something, right? But again, the idea is to, and what I also find interesting is that it used the table for the first ones, and then it kind of switched to a different format and then did the table again. So it would probably be nice to also give it a template here so that you give it created same output like we do here, right? Like a template. Okay, but let's do this, that we say, write 5 user stories and prioritize them. So there's a lot of requirements engineering here. Like this has nothing to do with code now, right? Because I just want to know what features are missing, and also how valuable they are and so on. So yeah, because this is about the whole software development lifecycle. This has nothing to do with development now, right? Usually a product manager would do that and would figure out what is missing. Or what you could also do is you could say, I have this user story, XYZ, is that already implemented? Or how valuable, how hard is it to implement, and so on, right? You can, as a product manager, also get a lot of insights already by just talking to it and using the stories that you already prepared. But in this case, what I wanted to work out is that okay, now it kind of analyzed the business rules and said, okay, password recovery and so on. It gave me a little summary here. Like password recovery is the most important one. And then it says like search is missing and filtering is missing. The contact detail is not enough. There's only too many fields in the contact, and not enough fields in the contact management system. There's only like the company name and then the company description. It says that here above, right? I just know it because it always does it. And the email verification was missing and so on. So now we can actually and it prioritized them. And also kind of if we go above here, we can see there's actually like a real, like the real story is here. As a user manager, I want to search and filter. So it used this template. It also kind of states why it thinks that this is high business value, right? Like the current page is only pagination and so on. So a CRM cannot search and functionality broke user. Yeah, so it's not very helpful without. And then some acceptance criteria as well, right? So it actually did that and then just gave me a summary here down below. And usually what I would do next is I want to let it implement these stories and say, okay, please implement them for me and so on. But what I could also do is...
Do you adjust sometimes I see that you have also a business description, maybe if you tell you some wrong thing, just above. Yeah.
Oh, yeah, let's go.
Yeah, again, we have seen that for each feature, we have a business description, again, just...
Was it this one here?
No, above. We have an array, above. If you scroll, yeah, again. Yeah, at the right, it's the business description for each feature.
Yeah.
Yeah. And if you iterate with the agent, maybe my question is, do you enrich this business description if the agent give you a wrong description, for example?
Yeah. That's a good point. Yeah. So yeah, what you usually do is if you know the system, then you could actually. So I mean, the question is, what is your goal here? Your goal is to have this catalog of the existing functionality.
Yeah.
So it would be good if when you are tasked to do that you actually know the system, right? And then you would kind of try to write it down for someone else so that someone else does not need to read the code, but can read this documentation. And then you are totally right. If you would see something wrong here, you would correct it. Okay. And then you would produce this catalog of correctly documented business document functionality. And this is what you can work on top of that for the next things you want to do. And the same goes here for the user stories, right? If you see something here that is now not correct, or you think the priority is not correct and so on, you can actually kind of say that, right? So let's assume
yes, but you're right, is when you know the system,
Yeah, you need to know the system to be able to verify that, or you need to ask it again, like, are you really sure, or can you verify that again? And if you do that multiple times, then the probability that it's actually write gets higher and higher, right? Because
yes,
it
the
will
feedback loop.
use
Yeah.
of the feedback loop again. Yeah. The interesting thing is that feedback loop is kind of a feedback loop in the agent, but our whole SDLC is also a feedback loop, right? Because in the end, we get the feedback from the users if that what we build is actually something that they wanted to, and we have this kind of say like micro feedback, like if the product manager explains the story to the developers, then the developers also give feedback, right? So there's also a feedback loop in there. And what we actually want to do is we want to leverage all of these feedback loops and not jump into coding immediately, right? The demo is just to kind of show that you don't need to code with this. You can do everything. You can do other stuff as well, right? And one last thing that I maybe want to show before drawing some diagrams that show the theory behind it is that you actually can now probably also say something like, and I will copy that over. I prepared that. I'm sorry, but and you will see the prompt here is that you can actually say like now also create like a documentation out of that, a diagram. And also that C4 thing here is not that interesting because it's more like a coding thing. But the second thing is much more interesting because it's kind of like a sequence diagram in terms of like usage. Like what is the flow of the application? How do I actually use it? This is more important for the product manager again, right? To actually know that.
And you need to
Yeah,
import a mermaid. I see that you tell to the agent to use mermaid diagrams. So
to
install the tool.
Yeah. I mean, I'm doing it here because I know that I want it to draw something, right? And now the question is, what should it use to draw? Should it kind of use plant UML, or should it use like whatever tool to draw? And currently, Mermaid is one of these that is actually working quite well. So we will not be able to render it here now. I mean, it drew it here now in the sequence. I could have like let's say like write the diagrams to diagram.md file, and then we can kind of open it in a second. Let me see if I can use one of my IDEs to open it. Give me a second. And it's actually able to draw very, very good mermaid diagrams. So there are other.
All architect will like your demo.
Yeah, probably. Yeah. I mean, the plant UML, for example, is not working at all. I don't know why, but it's like if the training data is bad or anything, I have no idea. But plant UML is like not working at all. And from experience, this mermaid diagrams are working quite well. So let me give you an example. Give me a second. I need to share something else. Share IntelliJ share. It's quite small now, I think, but this is the container diagram. But the flow here, this is like much more interesting because it now actually generated the actual flow through the application. I'm not sure if I can make it bigger here. Okay, I'm not sure how.
Okay, but you have all sequence the application. Okay.
Okay, great. That zoomed everything else, but not the. Wait, like, is it no? It's not. I cannot.
No, it's okay.
Okay. I can do it like. Yeah, it's zooming everything, but not the picture. I'm so sorry.
It's okay.
Can I open it in a? Okay, we need to reset it.
Maybe we will share the repo after the.
Yeah, I can do that. That's a good idea. Yeah, let me just zoom my IDE back to my default. Yeah, but what you will, I mean, you see there's the login page, and there's the React hook, auth hook, auth login, and so on, like auth module. It actually shows very well how the actual flow is happening in the application, also with the error cases here if something is not working. So it's actually quite impressive in terms of displaying the flow. If you use Mermaid, that is one of the so one of the good tips is to use Mermaid.
Yes, and the generation is less than 1 minute. So
yeah, it was quite fast, right? Yeah. Okay, so to get a little bit away from the agents and the code, I now want to show you a little bit about the thinking behind that. So why do we actually want to do that, and why do we not want to kind of, let me see, is this window here? You should see a whiteboard now. Can you see one?
Excalibur. Yeah.
Yeah, that's great. Okay, I just need to fix one of my screens here. Give me a second. Why can't I? Sorry, one second. I'll be with you in 1 second. Oh, the heck.
Do you have the unlimited token or not? It is depend on the cloud version.
I have the $200 monthly plan.
Oh, okay.
So it's not unlimited, but it's it's enough. let's
depend on the demo. Sometimes we need to clean
no, it's no worries. No worries. No. It never happened to me before, and otherwise I can just throw a little bit money at it. Not a problem. Okay, so let me kind of why did I show that to you? And so usually we have, let's say the process is we write code here, right? Implement code. And what we usually do is before we do that, so at least I do that a lot, is I do test-driven development. So I do implement the tests first.
Yeah.
And after the code, I do something
good thing.
Good thing, yeah. And then I do something like kind of pull request, and then there's code review, right? Like code review. So this is basically let's say when we call that somehow we call it this like the implementation part. And that is what usually the developers are doing, right? But when you look at the whole thing, there's actually also, after the code review, you have something like a retrospective as the team, right? Where you say what went well, what didn't went well, what should we do better next iteration, and so on. You also often do something like a stakeholder review, like not a code review, but a stakeholder review to demonstrate it and figure out is that actually what you wanted to. Then you release that stuff, and so you do a deployment, and then you get something like analytics data that will actually get their tracking data and so on, and you will probably also get some user feedback from some forms that they can fill in, right? Like a feedback form or something. So you have something like a step here where you reflect on what you did, and then you have something that you use to operate, right? Like operations. Then you have like monitoring and so on, right? Monitoring. And what you want to do is, so this is the end of the line here, and then in front of that, you kind of have like with spec-driven development, you need to do something like a plan. So plan in terms of story to tasks, right? Like to get
mapping and so on.
Yeah, and then you have before that you have something like, so this is maybe planning 2 in Scrum terms, and then you have like a planning 1, which is kind of prioritization, something like this. And before that, you need to do refinements, right? So like you need to say you have like a tech refinement maybe, and you have a product refinement. You know what I'm talking about, right? If you don't, just let me know.
Exactly. I like the example mapping.
Yeah. And then you have like and before that, the product manager has like stakeholder meetings and so on, right? There's a lot. So now I do some like ... here, because there is still a lot in front of that, but we don't need to look at all of that now because this is like really product management work, like user testing, synthetic jobs to be done analysis and so on. There's a lot of stuff that product managers do, but this is like far away from what we as developers do. But you can see that this is quite a large process, right? There's a lot of steps to it. And what we actually in the last decades, the implementation was also different the last decade because we had something like implement backend, and then we had like implement front end, and then we had like implement whatever, like infrastructure. So we as developers, we shifted from being like a very specific developer to become full stack, right? So this is kind of a pre-requirement here in my process. This is like full stack. And the next shift that is now happening is that we also become kind of more of a not full stack developer, or let's say full stack engineer. We become more like a full stack product engineer because we need to focus on all of the product things as well. And product things means in this scenario, like data analysis, user feedback. It means stakeholder review. It also means to do all of this stuff. I mean, we were usually involved in the tech refinement and so on. There was our involvement already. But now we have like a few steps here that we have never done that we need to learn. And we need to kind of figure out how to do that with agents, right? Because we don't only want to do the implementation. And if you have a keen eye, what you realize is in each of the steps, if we, for example, for the code implementation, we use our agent here, we have something like research, plan, implement. The agent does the feedback loops as well, right? So it kind of like, first it does some research in your code base, then it makes a plan on how to actually do what you ask for, then it answers what you ask for, and then what you usually do, you have some reflection step where you say, this is not correct, and so on. And then it remembers, so the agent kind of creates memory for itself that it will, next iteration, not do the same mistakes again, right? So we have like a feedback loop here.
And what is your point of view? Because we know that the coding part was never the bottleneck, but now sometimes in some teams we have a huge pull request, and you have a cognitive load for the code review.
Yeah.
So what is your advice maybe for this part?
Yeah. Okay. So I mean the question is, do you actually need to do the code review anymore? Because I would suggest that I mean, we are not here in terms of the story yet, but if you do that right, this whole thing here, you don't need to have the code review. What you would want to do is so let's take us a few more minutes further, and then we can discuss about the code. So what you can see here is this loop, right? This research, plan, implement, and reflect loop that you have in each of the conversations you have with the agent. And you would do that when you implement the code, you do that when you implement the tests, you do that when you kind of, as you saw, when you do the product refinement maybe. So you have this inner loops of the agent. And this outer thing, if you look closely, is also the similar loop, right? It's like implementation is the I, reflection is the R, and you have a plan, you have that as well here, right? So basically what you do as a team or as a full process is the same loop. You have a plan, and then in front of the plan, you have the research. So basically, you have this outer loop, which is also kind of similar to the agent loop. And what you now need to figure out is how to actually, each of these steps in the loop and in your outer loop, how to use an agent in these steps and build something that is using the outputs for the next agent, right? So, and when you put that further, this thought, then you actually, as a developer, you shouldn't really work on the specific feature requests in terms of like this is the feature XYZ that should be built into the system. Okay, I take my agent and build it. You should actually build this whole pipeline that will build the feature for you. So you should kind of go one abstraction above and say, well, maybe let's just write a tool, and this tool will write the user story for me. And then you start by writing a very small tool, which is the tool of implementing the code, right? Because this is what you know how to do. So you write some agent that is going to do the implementation very well. And then you realize, oh, now I could also write an agent that is doing the test implementation very well. And then you couple them together and say, okay, this agent is doing the test thing, and this, and then you can have a loop. Basically, what you currently do is you say your agent in this loop here, below here, write tests and write the implementation. But what I would do is I would say, make a script. And the first part of the script is going to do the test implementation with an agent. And the second part of the script is going to do the code implementation of the, so for Claude, for example, you can do Claude minus P or -P, and then you can say implement the tests, and then it will, and you can do like implement the code. I mean, you can obviously use like skills for that and so on. But the interesting idea is that you can then have an SH script, a bash script, SDLC system, or like kind of production line that will just call both of them one after another, right? It can just say, and then you as a developer, you don't need to manually interact with Claude and say, now write the test and now write the code. You basically have a script now that will do these steps.
You orchestrate for you.
Yeah, and it's not orchestrating. It's kind of like a very deterministic workflow, right? Because you say, write the tests, write the code. You actually, in this case, you don't want to have an orchestration because you actually wanted to first write the test and then implement the code, and you don't want to have something like a non-determinism thing. I mean, otherwise you could have an orchestrator that will do that. And then if you think that further, you could also kind of say Claude-P, create a pull request, and so on, right? And what will happen is that you will kind of extend the script with all the other things as well, right? Like from time to time, you will notice, okay, now so you can only do that when you are really sure that your implementation is actually accurate, right? So in the beginning, what you do is you do this inner loop here manually, and then because of the reflection step here, you collect like information, and at a certain point you will say, okay, now this thing is implementing a lot of features on its own very well. So now I can kind of use that as a script because I don't really care about the details anymore. And if you do that for all the steps, so if as a product manager, you kind of figure out how to do a user story with a Claude, then you can actually put that into the process here as well, right?
And so the reflection part in the inner loop is very important.
Yeah, that is very crucial. And the moment you don't need that anymore, because you manually are aware that this is okay, you can basically put that into the script and then automate that thing completely away for you, right? Because you don't. And what is actually interesting is, let's assume that you have all the steps in here now, right? Like all the steps are like the full pipeline is here right now. Then you basically only need to have an idea and put the idea here in there, and it will produce you, maybe do a canary deployment to some branch that is canary, and then you can kind of only have here in the deployment or anything, you can say like, do I want this feature or do I not want this feature? That looks now, you don't need to do prototyping, don't need to do any of that stuff, because you have basically the canary deployment of the application change. And then people can, a product manager or you or whoever wants to decide, can basically decide, oh, this is actually a nice feature to have, right? And so you get this whole script is now also this reflection loop here, right? This research plan, like maybe some here are doing the research, some scripts, and then you have, these are the implementation scripts, right? And so on. And one key thing to the reflection. So in the beginning, what you will do a retro, and the retro is also a reflection, because you look at the full process that you've already built and get insights here. You can do that with Claude as well. If you kind of prompt it, look back at our latest implementation process, blah, 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 and provide feedback, what you should remember. And then it will analyze all the steps and remember that in your code base. And this is actually also something that you could automate, right? So you don't need really, as a human, need to do reflection. You can also let an agent do the reflection. And then it kind of gets very interesting, because you have this self-promote. And then you are back again at just looping 5 times through the same process for the same feature. And then basically saying, you decide now which one was the best implementation. And then also remember why this was actually the best implementation, what you did differently and in the others, and then put that back to the beginning in terms of like a Claude MD file or something. Yeah, and that is actually what we do for some of our clients at the moment. So we have a client where we run.
When we integrate this in Teams, because you can help teams to integrate the AI agent, for example. What is your advice to keep the human in the loop, but in terms of teams? The whole team need to work on this script, for example, or?
So what usually happens is that you first kind of, so at least when we do it, what usually happens is that you first map your current process, and you say like, so let's assume everybody knows about this, what you can achieve, how this is working, how agents are working, and so on. Like theoretical knowledge is there, and no training is required, and so on. Then you are at the point where you would want to figure out how to actually use that now, right? Like everybody knows what a skill is, what a sub-agent is, what is a team of agents, and so on. And at this point, what we usually do is we map out the current process. And this is different for everybody, right? And this is like a generic, maybe best way, but maybe also not the best way. So some generic idea.
Yeah.
And then what you need to do is you need to, as a team, figure out where is our biggest bottleneck at the moment. And as you said, it's usually not the coding. It's usually somewhere else. And then you need to figure out, okay, let's take this step and agentify it somehow. Like so for example, let's assume it's the product refinement step, because it usually is the requirements engineering thing. Then one thing that we usually advocate is do transcriptions. So just kind of record all these meetings and figure out how to build an agent that will actually do this requirements thing here for you. And then you can actually do this, and you have a human in the loop there, right? Because you will still review it, you will still say, okay, this is good, and so on. But at a certain point, you will realize, okay, we kind of figured out how to configure this agent so that with every transcript we throw at it and all the documentation and so on, it will always produce a very nice user story. So we don't really need the human in the loop anymore, because it's now very good. And you can either in parallel or sequentially figure out, okay, where's our next bottleneck, right? What is the next thing where we want to do that? And
each
this
step
is how
you apply the inner feedback loop, and in the reflection part, you need to see how we can automate the task.
Yeah, exactly. You have these inner reflections, and then you have the outer. I mean, if you really want to kind of step up the game, so what usually happens is you optimize all of the inner things here, that they are quite good. And then at a certain point, you say, okay, let's kind of try to build a pipeline out of that. And then you really need the outer reflection here as well, because if you don't have that one, you will not be able to reflect on the whole pipeline. Yeah.
So this the goal is to break silo, and the whole team should work together. Yeah.
Yeah, exactly. So I mean, you were asking about the code review. I would do that until you know that the code implementation agent is producing well results. So if you do code reviews and at a certain point you don't really need to do code reviews anymore because you feel like they are always okay, then you should probably not do the code reviews anymore, because then you know that this agent is able to produce well code on its own.
Yeah,
But the
I
interesting
see
thing
some
is,
skills or
yeah,
command in order to execute a mutation testing, in order to validate the code.
yeah, exactly. And what is interesting is that what you will actually not be able to achieve, and people often make this mistake, is that this implementation thing is a one shot, right? It is implementing and then it's good. That is not going to happen. This is also not how developers are working. We shoot something and it's maybe working, but then after that we know, or we realize, okay, it's horribly implemented. Let's kind of make another loop and make it better, right?
Okay.
And
Refactor.
yeah. So if you configure this agent, build loops, and don't assume, or a lot of people that we work with have this high expectation of the agent will produce the best result on its first try. It will not. It is not going to do that. And you can. There's no way you can configure it that it will do. It will never do that. It will not be able to do that. But what it will do, it will be able to do that if you loop 5 times over it. So the easiest strategy to not need to do code review anymore is just to let it loop 5 times over its own implementation. And then it will kind of, as we humans, restructure things and figure out, okay, I could have done this a little differently and so on. Oh, okay, it's still working, great, and so on, right?
But yeah, we have another concept. If we remove code review because we trust the implemented code, we have also the principle of the accountability of the code. If you put some code in production but without reviewing it in teams, I mean, what is your advice in terms of accountability of the team? Of the code
you mean
producer.
the accountability? Yeah. I mean, the question is, what are you actually accountable for? Like, are you accountable for the code, or are you accountable for delivering this product, right? And you can still, as a team, have the accountability for delivering the product, if you make sure that your pipeline is actually producing the right code, right? So
yeah,
it's a little bit like with manufacturing. So let's assume you are manufacturing a doll, like a plastic doll.
yeah,
What you, as an engineer, you are not building the doll yourself, right? I mean, what you do is you kind of think about, okay, this is how the doll should look like, and now you build a tool that will produce the doll for you, like a mask, right? And then you have this mask, and then you put the liquid plastic in it, and then it will freeze or something, like it will cool down, and then you will have the doll, right? And you are still responsible for the doll, but you will never build the doll. You will build the mask and the machine that will put the plastic in there and so on. And this is kind of like what we as developers are also now doing. We need to build the machine that will produce the product, and we need to make sure that there's quality gates in this machine.
Yeah, but like you said, it's a big shift. We move the how you say it's a new level of abstraction. Like
yes, this definitely is. It's, for me, it's also super hard. So when I start, so I do that a lot, right? That there's a client that says, well, we need to build something here. I have never seen the repository, right? I never seen the code in it, and then I'm throwing in this team. And what is kind of interesting is I'm not starting with building the abstraction. I don't even know what the right abstraction would be, right? So I need to do the real story and do it manually with Cloud Code. It's kind of tedious if you know what these machines can do, but you need to do that in order to figure out how the machine should look like. And the skill that you actually develop as an engineer now is to be able to really quickly build this machine. So you need to really quickly figure out, okay, which parts can I automate? What do I need to configure here so that this can work on its own? And where do I need a human in the loop? Or, okay, how fast can I get rid of the human in the loop? So you're not thinking about the product anymore. You're thinking about this machine, right? And while building the product, you are thinking more about the machine than you are thinking about the product itself. And this is the skill that actually is needed. What is super interesting
to work on this. Yeah, we need to work on this because the first reflex is when something is wrong. we need to deep dive into the code. Okay.
Yeah, it's exactly. Yeah, and what you should actually figure out is why did the machine make a mistake, right? Like, how should I change the machine that there will not be no mistake? Like we do when you do manufacturing, right? And in some manufacturing plants, I know a lot of logistic companies, for example, they need to kind of figure out if the right stuff is in the right box and so on, if the right amount of stuff and so on. And they do that manually in the beginning. They have people standing there in the logistic line and just looking into the thing and say, well, this is okay, we can move it on. These are not very expensive people, but still it's very slow, right? And then what they figure out is, we could use a camera for that. So what they do is they build a camera on top, and then they say to the human, I'm so sorry, we don't need you anymore. There's a camera now. And this is basically what we need to figure out for us now as well. We want to be the ones that are building the whole process and the cameras and so on. And we do not want to be the people that stand and check if the box has the right amount of stuff in there.
Exactly. And in the reflection part, the big mistake is to do it manually, but we need to import the code,
exactly. I mean, what you could do, and what is actually a very good tactic, is you could manually change the code and say, like, basically produce the result that you intended it to do. But then there's one crucial step that people forget. You need to tell the agent that you corrected it for the agent, so that the agent then is able to read it again and say, oh, well, this looks better. And then you need to say to the agent, remember what I corrected, and or figure out why I corrected it and save that away for you so that you kind of know that.
Yes, and to avoid reproduce the same mistake.
Exactly. Yeah, exactly. One thing is to reproduce the same mistake again. And the other thing is that if it does the same mistake again, that it will on its own review it and figure it out and correct it in its second loop, basically. And people forget that. People correct it and then move on. And then they often have to start over every time, right? I had a team here, they were building some tests, and then they told me it always produced the wrong test, and it always was not how, and I needed to tell it 15 times, and then finally it built it correctly. And I'm like, yeah, great. And what did you do? Yeah, I implemented the next test, and I needed to tell it 15 times how to build it, and finally produced the right. I'm like, yeah, but why don't you kind of just save your requirements to the test to a file, and then it will kind of know what you want it to do? And then we kind of saved that to a rules file, right? Like, how should tests look like? We actually didn't write the rules file on our own. I just told Claude, look back at our last 5 conversations. What was the stuff that we always corrected, and just write that to a rules file. And then the next time he said implement a test, it did it correct on the first try. And he was looking at me like, this saved me like 40 minutes of fighting with Claude. And I'm like, yeah, you're just using the thing incorrectly, right?
But it's an interesting part because it's the beginning, we see some individual usage of AI agents. But in the team, when we need to reflect on the skills of something like that, do we need to add some validation step or something like that in order to see if the whole team is okay to add new rules, for example?
Yeah, that is this retrospective for me here, right? So usually we do that in a Scrum way, right? Where we just sit down every 2 weeks and discuss what went well, what didn't went well. But I could also just do that as an agent, right? I could save these learnings and the conversations. I could save the sessions. Cloud Code is actually, if you use it on a single computer, it's doing that automatically, right? But let's assume these are multiple computers. You can just store it to a cloud somewhere, right? It's just JSON files. And then here in the end, you don't do a human retrospective anymore. Who cares about humans? What you do is you just, and your retrospective is much faster if you do it with an agent, because you just tell it, look back at all the conversations, like what could have been better, and present like an improvement idea on our machine, right? How could we improve the machine? And then it will spit out like 5 nice ideas, and then you can think, oh, this one, I'm going to try this one out, and then you're going to have a better machine next time, right? This is, and maybe one last interesting thing, because we are kind of running out of time, but I think this is so important to get this skill of, let's call it like building the machine, this abstraction thing, because what happens if there's a new model and there's a new model release? You basically need to rebuild your whole machine.
Yeah.
The reason why you need to do that is you don't really know the defaults of the new model anymore. Because what you do with these files and these rules is you just change the default behavior of the model. And the model always has the same default behavior. It will always, it will not be super deterministic, but it will always be very similar in what it does. And if you wanted to write the tests first, and it is not doing that, it will never do that. So because its default is not writing the test first, but you can kind of steer its default with your rules file. But if the new model has a default of writing the tests first, then this rule file is kind of like very obsolete and maybe even doing harm, because maybe the new model is so smart to know when to write tests first and when not to do it. So basically with your rule, you're making the new model maybe dumber than it actually is. So in my case, what I do is I often throw away the whole machine and kind of do it again from scratch, because it only takes me like a day or something to build this whole thing, right? If I'm alone. If I'm a team, it takes me a little longer, but I can practice that as a team as well, like how to build this machine. And then it will probably only take me 2 weeks or something to rebuild the whole machine.
Yeah.
And I can also kind of, usually what you do is this is very brute force, right? Like with the loops, you basically, you are using the same model and doing the same prompt but if you kind of have the whole machine here, you can actually think about doing certain steps with different models, right? Because maybe some step is fast and easy, and so you don't need Opus, you can just use Sonnet. And then there's another step where you definitely need Opus and so on. So what you would actually not need to rebuild the whole thing, but you can try to rebuild certain things of it because you want to try out a faster model and so on. Yeah, and this is basically what you as a developer need to figure. Like you need to get a new gut feeling, right? You need this new. Like we have that now with code, right? If I see your code, I can. Last example. If you have junior developers, have you seen a junior developer read code? It's like you're getting insane because they are like reading each character. Like this is like, oh, this is like function. Oh, when you as a senior developer read code, you just look at the whole file and you know what this thing is doing, because you know the lining and you know what parameters it's just in your head. You compile it in your head immediately by visually recognizing the whole code, right?
But it's interesting for senior developer in an old team. We build a mental model of the code,
Yes.
And it's what is difficult for junior because with the AI agent, but the value in the team is not the code itself; it's the mental model of the team. So it's a difficult moment for junior, maybe because by coding you build also the mental model. I think it's a problem for junior because without coding, you need to find another way to build this mental model.
Yeah, but I would say that your mental model is not necessary. It's the wrong mental model. You don't need that mental model anymore. What you need is to have this mental model of the machine. You need to quickly figure out how will I be able to build this machine. And I see some, I would say like senior AI users that actually are able to scan the conversation while it's happening, and then already knowing in their heads how this machine would need to look like, because they see, okay, now it's going in this direction, now it's reading these files, and okay, no, I need to kind of steer it in this direction, and then you already, and then there's someone who has never done that or is very like junior with these agents. They don't even know what's happening there, right? And because it's like scrolling away, they are, oh shit, I missed that one, right? It's even harder than when you write code, because when you write code, you can just like see it statically. And for the for the senior people in AI, they basically they look at it at one conversation and then they start building the machine because they actually now already know what is going on here. Like
yes, and I think for senior, he know that if it's wrong, he can deep dive and fix it. Yeah, but
yeah,
it's not the
exactly.
case
Yeah.
for the junior.
Yeah. Yeah, but the question now is, and this is the maybe the last sentence to leave you every like. I think we need to build these new mental models. We need to, as
Yeah,
developers,
exactly.
we need to actually be able to, what you described with the debugging. I'm not debugging the code anymore. I'm debugging the agent, like reverse engineering the behavior of the model. Why did it do that now? It should have looked there. Why did it look there? And then I see, okay, maybe I'm missing some context files, some architecture documentation, something that would have pointed it to go in the right direction. And then I provide this file. Or actually I just say, okay, I corrected sometimes and say, now write these insights somewhere, and then it also is there already. And these new mental models, this is what we need to aim for. This is the new seniority, right? Like figuring out these new and this is very hard for people that are very very fixated on their mental models that they have, right? And
we need to move to this new way of mental model. And I see some interesting topic about actually for the time being we optimize the code for the human in the loop in the implementation part, but maybe in a few months or years the code it will be optimized for agent and not for human. Yeah. So
there's actually a repository
intent-driven
for that.
development. Okay.
Yeah, it's called
Nice.
intent-driven development, and there's also I think on GitHub intent. Let's see if I find it. There's actually an implementation already from someone. I don't know if it's this one. No, it's something else. But I would need to look it up. But there's someone who actually has ideas on how this language would look like if it's an intent-based language, right? Not like you have a if statement with some conditions or something. You write it kind of like an intent. I have an intent here, and this is enough, right? So you build in. Yeah, that's super interesting. I'm not sure if this is going to. Yeah, this is going in the direction of the argument that the LLMs and the AIs is a compiler, but for me it's not like a compiler. The abstraction it's a different kind of abstraction than the compiler abstraction.
Yeah.
So I'm not really sure if these new languages will develop because we have enough languages to do everything we want, right? It's not getting better with the new language because we are not. The idea of this intent-driven thing would be that you can use this intent language to more precisely say what you want. But the LLMs are actually trained on human language, and sometimes it's even better to provide documentation in written human form than in JSON. For example, open API documentation is really helpful for the AI if you provide it as a markdown file. If you kind of write, not as a JSON file, but as a markdown, because it can read the markdown better and interpret it better than the JSON file. So I'm not really sure if we need another program, because I think the language is currently specific enough to do to tell it what we want. Anyways, it has been a pleasure.
Yes, I see another standard for it's not JSON, it's another a tune for
tune. Tune.
Yeah.
The idea of tune is it's just to encode the data, right? Because JSON is kind of verbose and CSV is kind of like not very helpful because you lose the information about the rows very, very early in the first one. And tune is kind of the idea to encode it a little bit better. Not sure.
Token-oriented object notation, and you can see it compares some data from JSON or the standard.
There's also BAML. BAML is also kind of nice.
BAML, okay.
BAML is the idea for if you build an agent and this agent is writing its own prompts, then you would need to have a language to write these prompts. and this is this is the language you can use to let a program dynamically write the correct or best prompts for prompting the LLM.
Yeah, and the goal is to reduce the token consumption also.
Yeah, genau. Yeah, exactly.
Okay,
Thank you so much. It has been a pleasure.
Yes, if we have some links, send me after the meeting, and I will add it on the comment of the YouTube channel.
Yeah, thank you so much. It has been a pleasure. I hope it was fun, and I'd be super happy for some feedback and follow up comments and so on. It was I really enjoyed it.
Yeah, it's a big shift for all teams. So thank you so much, Benedikt, and I will share the video when it's ready.
Thank you so much.
Thank you.
Thank you. Have a great day. Bye-bye.
Bye.